So let's discuss how to find the Fisher information for a random variable x, which is distributed exponential lambda. So the first thing we need to do is to write down the likelihood function. So that's going to be L of lambda is lambda e to the minus lambda x. Then from that, we're going to find the log likelihood function. So taking some logs, that's just going to be the log of lambda plus the log of e to the minus lambda x. But we can write that even more simply as just the log of lambda plus minus lambda x. So we'll change this to a minus sign here. Okay, so now that we have this, to find the Fisher information, we need to use the following equation. So the information for lambda is the expectation of the derivative with respect to lambda of the log likelihood function, all of that squared. So what we've already found out here, that's this part right here. That's the L. So now we're going to want to take this and take the derivative of that with respect to lambda. So I'll write that over here. So if we take d lambda, what do we get? So the log of lambda here, that just becomes 1 over lambda. And then here, taking the derivative of this term, we just get minus x. So now this part here, this is this part here, so we still need to square it. So to make things a little simpler, let's get some more room on the next page here. So what we have now is the expectation of 1 over lambda minus x, all of that squared. So if we expand this term out, we get the expectation of 1 over lambda squared minus 2 over lambda times x plus x squared. And so now we're able to carry the expectation through. So this is the expectation of 1 over lambda squared minus the expectation of 2 over lambda x plus the expectation of x squared. But since we're taking the expectation with respect to x, our random variable, this term just becomes 1 over lambda squared. This term is minus 2 over lambda e of x. And if you recall, for an exponential random variable, this is just 1 over lambda plus e of x squared. And so to figure out this part here, let's just do a little side note up here. So we know that the variance of x is e of x squared minus e of x quantity squared. So from what we know about the exponential distribution, this here is 1 over lambda squared. This here is the thing we want to find out. And this here is just 1 over lambda quantity squared. So what we find is that e of x squared is just 2 over lambda squared. So let's replace this with 2 over lambda squared, which we see is just the opposite of what we have here. So these two terms will cancel, and what we have left here for our Fisher information is the final answer of 1 over lambda squared.